let's talk about background algebra. So it's not something that is specifically AS level, but what's important is that you're on the right page as you get started. A reminder of a few things that you need to bring through from IG as you move into AS, because AS, it's all about algebra. Everything we do breaks down to algebra. So let us make sure that we're comfortable with like terms, removing brackets, factorization, multiplication without that little x, and then, of course, the big one, fractions. We are going to be using fractions a lot, and you need to be comfortable with fractions. So starting at the very beginning, identifying like terms. Okay, so whenever we are simplifying expressions or simplifying parts of an equation, we want to be looking for those like terms that we can then combine to make life prettier, easier, and simpler. So when it comes to different types of terms, we are considering constants, we are considering variables, and we're also considering exponents. Okay, so constants are our numbers: -3, 2, 5/2, 153. Any number is a constant, okay? Because that number has the same value irrespective of what question you're working in. A 3 is always a 3, wherever you use it. Variables are our letters because they can change. X, Y, A. Each of these can be something different in question 1 and question 2. X can equal 3 here, X can equal -2 over there. And the thing is that that means they're variable. Something to remember, within one question, each variable can only have one value. So you can't say X equals 2 in a question and then set up another equation and say X equals 5. The only difference here would be like for a quadratic, when you were getting out those two answers for one quadratic. For X has two values there. Okay, but if we're dealing with X in different situations, then it wouldn't be the same. If we have different situations, you need different variables. Okay, you can also use subscripts if you want to indicate different variables. You can use x1 and x2. We're going to use this as kind of approach when it comes to trig, when we're looking for different solutions to our equation. We'll say x1, x2, x3, x4, okay, because it's different solutions even though we're working off the same equation. So preferably use different variables. When you're integrating, you're going to be integrating twice in some cases. So you have a C and a K rather than two C's or two K's, because in those things, you've got two completely different situations. So you need two completely different variables. And then our exponents, remember that an x is not the same as an x squared. Okay, that means that an x term and an x squared term are also not the same. So if it came to building terms, a 2xy, this is a term in xy. So it's different from -3x, it's different from y/4. Each of these are different types of terms. Yes, they've all got constants in them, but because we have different variables going on, then we have different terms. So we wouldn't be able to combine any of these three. Remember, your key goal is always to collect like terms and simplify as soon as possible. Don't leave a 2x plus a 3x in a few lines. It's 2x plus 3x is 5x. Finished. Carry on. Simplify and then move forward. Quite closely related to like terms is removing brackets. So again, it's one of those little things, but if you make a mistake here, then it can knock on. And when it comes to AS, your marks are dependent on a fully correct working. It's not just all about the answer. You can get the correct answer and make mistakes in your method, then you're going to get a 0 because it's all about the communication of your method. So when you're removing brackets, you're going to multiply everything. And you're going to watch your signs very carefully. So something like 4x plus 2. Okay, we need to go in to both. So 4x plus 8. Minus 5. We would have x plus 1, for example. Again, that minus 5 must go in on both. Minus 5x minus 5. And how about minus 2, x minus 3? Again, minus 2 onto both, so minus 2x, watching the signs, plus 6. So even if we step it up and we have 2 brackets, x plus 3, x minus 5, we're going to end up with a quadratic. So FOIL, first, x squared. Outer minus 5x, inner plus 3x would give us minus 5x plus 3x is minus 2x. And then last, 3 times minus 5 is minus 15. And yes, it's AS now. You are expected to start getting the point now where you can do that outer and the inner together and just write down a final answer. If you're a person who struggles, then show that middle step of there's my outer, there's my inner, then combining the like terms. But be aware that this isn't IG anymore. You've moved on to AS, and therefore your basic skills are also expected to improve. When it comes to making even bigger multiplications, x plus 2, x squared minus 2x plus 1, you've got 2 options. You can either track each one like this, or you can open it up. X squared minus 2x plus 1 plus 2. X squared minus 2x plus 1. And then you're going to multiply in on both of them. X times x squared, x cubed. X minus 2x squared plus x. Plus 2x squared minus 4x plus 2. And then, of course, you're going to collect like terms before you move any further. So we have an x cubed minus 2x squared plus 2x squared, it disappears. Plus x minus 4x, so minus 3x plus 2. And now you see we're actually dealing with 3 terms instead of 6 in this particular case. So it's a much simpler version to move forward with. And that's why we're always going to collect like terms before we do anything further. Because it's always about where are we going next. Okay, so moving from removing brackets to putting them in. Let us briefly touch on everybody's favorite, factorization. So factorization is about putting in brackets. Why? To simplify things, to make them more efficient, to make them cleaner and neater. Okay, so we are simplifying expressions. We're neatening up expressions. We are making expressions, in some cases, easier to work with. And when it comes to quadratics, we're going to use factorization to solve equations. No matter what you're doing, you're looking for highest common factors of terms. Okay, any kinds of 2-type or 4-type factorization. When it comes to those 3-term quadratics, the ax squared plus bx plus c, we're actually going to deal with those separately in a whole entire lesson, because factorization of quadratics is so key and so important and something that you're going to be doing a lot of. So in this case, we're talking about things like a 2x plus 6, and a squared b minus ab squared. A px minus qx plus 2p squared minus pq. Okay, so 2 terms, 4 terms are sort of more standard factorization rather than working with quadratics. And what we're always doing is we're looking for the highest common factor of the terms. So the highest common factor of 2x and 6 would be 2. Take out the 2. 2x divided by 2 is x, 6 divided by 2 plus 3. A squared b minus ab squared, highest common factor here would be 1a, 1b, because there's 1a in both and there's 1b in both. Okay, taking out an a and a b here leaves us with an a, taking out an a and a b here leaves us with a b. So AB, A minus B. When we're faced with 4 terms, then it's about doing them 2 terms at a time and seeing the magic that appears. Wonderful stuff. Px minus Qx, what can we take out? Common factor here is an x. And we're left with a P minus Q. 2p squared minus pq, what have we got common? Actually, I wrote this one down wrong, sorry, there's a 2 here. 2p squared minus 2pq, our common factor there is the 2 and the p. So plus 2p, and the magic that we're left with is a p minus q. But we're not finished factorizing, because we now have 2 super terms, we can call them, because that's all multiplied together, it's stuck together. That's all multiplied together, so it's stuck together, so it's a super term. Okay, but in both of these super terms, we have that p minus q. So we can take him out, p minus q. And we're left in our first super term with an x, and in our second with a plus 2p. And we are now fully factorized. And in this case, we ended up with 2 brackets. And this approach actually links quite nicely into how we can find a root to factorize ax squared plus bx plus c when our a is greater than 1. But as I said, we will cover that much more thoroughly in a whole entire lesson dedicated to the factorization of quadratics. So, factorization, brackets, and signs. They are 3 things that are key, that are crucial, and unfortunately, they are also the originator of far too many silly mistakes when it comes to AS Maths. So much so that when you look at assignment marking, you may well want to swear when you see these things. So the B word in AS Maths is brackets. The S word in AS Maths is signs, and the F word in AS Maths is factorization. Do not forget these 3 key skills. Okay? They are the ones that are going to take you through all the nitty-gritties of your calculations. It's really important because it doesn't matter how much of the concept you understand, you've got to be able to back that conceptual understanding up with the detail of your calculations, the working through the nitty-gritties. And these are things that come into play so often and so strongly that there's no getting away from them. Last thing I want to talk about, also a bit sort of basic, but we need to cover it, and that is multiplication. So multiplication, 2 times 5 equals 10. Agree? 2 times 5 equals 10. 2, 5 equals who knows what? 2, 5 equals 25. Okay? 2 times 5 also equals 10, but it is less efficient, it is less neat and tidy, so we tend to not use the multiplication sign. Also, for those of you who write your x's, let's talk about that here at the same time. Our algebraic x is curly because this is a multiplication sign. So this is a variable. This is a multiplication. So if you are a person who still is using a plain x, please start to transition towards a nice little curly x. When you use a capital X, then he becomes a big one. This is also a variable. Often used like for a point. Okay, whereas our little x would be so 2x plus 3 equals 10, and then we're solving for an equation. Okay, so when we capitalize in math, we lose the curls, but our lowercase x is lovely and curly. So when it comes to multiplication, the ones we are aiming for are these two. Something else to bear in mind while we're on this little topic is that if you write minus 2x plus 3, this is minus 2x minus 6. If you write x plus 3 minus 2, then you've got x plus 3 minus 2, which is x plus 1. These are two very different things. If you write x plus 3 minus 2, then you've got minus 2x minus 6 again. So the difference is, did you include that multiplication or not? These two are both multiplications because they are stuck together here with a multiplication and here with a multiplication. This one, there is no sticking. That's minus sign is separating those two. If there was something stuck to the back of this bracket, it would be a 1. There's no thing that's saying multiply this minus 2 by this bracket. So please remember this. You're going to bump into this when you come into sequences and series. It is crucially important that if you've got a minus after a bracket, then you need to put that into brackets if you want to multiply. If you do not want to multiply, leave it there. Leave it as a subtraction. But if you want to multiply, there must be that multiplication indicated. Okay, so that is now covered as like terms. Moving back is factorization and multiplication. So the last one, the most crucial piece, the one that is so friendly, fractions. So if you do not believe that fractions are your friends, today is the day that you are going to change your relationship. You will be sending your Valentine's letters to fractions. We are going to work with fractions. We have to work with fractions. Oftentimes we won't be working with decimals because they're not accurate enough. So we're going to work with fractions that even have surds in them, fractions that have pi in them. A lot of no simplification because we want exact answers in pure maths. So fractions are your friends. You need to be comfortable with working with them, and you need to be comfortable with working with improper fractions because more often than not, we actually work with the improper fraction, not the mixed number. Because again, if we're going to use it further on, if we're using it for something else, if we're putting it into another equation, that improper fraction is what we want to calculate with. So that's what we work with. So running through some fractions reminders, if it comes to addition and subtraction, that basic golden rule, the denominators must be the same. So we are looking at something like 1/2 plus 1/4. Can't do that, can we? Because 2 and 4 are not the same. But we can convert them both out of 4. 2 out of 4 plus 1 out of 4 equals. Then we add across the top, keep the bottom, 3 out of 4. So that's with numbers, but it's exactly the same when it comes to algebraic fractions. A over x plus c over y. Well, can't do anything because x and y are different. So what would our common denominator be? Often is the case for algebraic fractions. We're just going to multiply them over xy plus over xy. So if we're going to multiply the bottom by y, we've got to multiply the top by y. So we would have AY on top. And you can see straight away, those y's would cancel if we simplified this fraction, and we'd be left with A over x, which is what we started with. Multiply the bottom by x, multiply the top by x. And again, we can see immediately if we were to simplify this fraction, we would be back to cy. But now we can go AY plus CX over XY. Because of this plus, we can't cancel anything here, and this is our simplest form to leave it in. Okay, we're going to need more space to do multiplication and division. So fractions continued, friendly fractions continued. Let us talk about multiplication. So here we go across, top and bottom. We're going to multiply the numerators and the denominators. For addition and subtraction, we just add or subtract numerators. The denominator stays the same. For multiplication, everybody gets involved. So here we're talking things like 2 over 3 times 4 over 5 equals 2 times 4 is 8 over 3 times 5 is 15. Straightforward multiplying across. Same thing for algebraic. A over x plus times c over y equals a times c over x times y. When it comes to multiplication, we can make life a whole lot easier by cross-cancelling. But it is important to remember the only place you can cross-cancel is when you are multiplying. Can't cross-cancel for addition or subtraction or division, only in multiplication. So here we're talking about things like 2 over 3 times 6 over 8. We've got common factors on our cross. 3 goes into 3 and 6, so there's a 1, there's a 2. 2 goes into 2 and 8, there's a 1, there is a 4. So this equals 1 times 2 over 1 times 4, which equals 2 1/2. Always simplify your fractions. Okay, you can leave them top heavy, leave them in proper, but always in simplest form. So if we do a similar sort of thing in algebraic fractions, we could do a squared x over b times b squared over 3x. Again, when there's cross-cancelling, get it out of the way. So x and x, there's 1b, which takes out one of those. So we are left with a squared b over 3, which we could also write as 1/3 a squared b. In some cases, we're going to want to pull that fraction out so that we can see the fraction separated from the variable. So be familiar with pulling them in and out like that as well. So the last part of our friendly fraction story is our division. So flipping times. Or in fancy terminology, multiply by the reciprocal. So what we're going to do here is we're going to take our fractions, so 2/3 divided by 5/6, for example. Okay, well, 2/3 divided by 5/6, we don't have mixed numbers to deal with, often the case, because we are working in our improper fractions. So if we did have mixed numbers, we'd have to do a conversion first. But then we can say, okay, fraction divided by fraction, we're gonna flip in times. So 2/3 times 6 over 5. Now in multiplying, we can cross cancel. 1 3, 2 3s. 2 times 2 is 4 over 1 times 5 is 5. Exactly the same rules when it comes to algebraic fractions. If we have ax divided by cy, this is exactly the same as a over x times y over c. Okay, as soon as you change to a multiplication, you flip that second fraction. You get the reciprocal. Okay, a times y on the top over x times c, cx. We generally write our variables in alphabetical order. It's a nice way to keep track of them, and then you know that you've got the same type of term all the time. So if you are struggling on any of these things, if you're not quite friendly enough with fractions yet, please take the time as you get started with this course in order to get these areas sorted, because they really are going to underpin so much of the work that you're doing moving on from here.